Hello everyone, welcome to my channel. In this video, I have this question here on complex numbers to work on. We are to evaluate the square root of 3 minus 4i. Now, how do we approach this? Well, like I said, complex numbers, we have a couple of things to talk about, and I'm going to address those things as I go through this question. But otherwise, I'll come back again with another video on complex numbers to just talk about the basics and a couple of mathematical manipulations of complex numbers. Now, in this one, we have the square root of 3 minus 4i. We have to evaluate this. So how do we approach it? Well, the square root of, like I said, 3 minus 4i is what we have to deal with. Now, complex numbers always exist in the form of the real part and the complex part. So we are going to say let the square root of 3 minus 4i be equal to some number a real number, and some number b, which is a real number, and then I. This is the complex part, and that's the real part. Now, our job is to find the values of a and b. So naturally, the first approach would be to square both sides. So we're going to say squaring the left-hand side, which is 3 minus 4i. We have to square this, the square root of that, we square it. On the right hand side, we have to say a plus bi. We have to square that. On the left hand side, you'll agree with me that this cancels that. So what do we have on the left? Well, on the left, we have basically 3 minus 4i. On the right hand side, expansion of this expression here would be a times itself, a squared. Please look at some of the videos are presented on this channel involving algebra, expansion, factorization, and all that stuff. You'll see the shortest way to expand this is as follows. Take this, multiply by itself, you get this. Multiply this by that, and then double that, 2abi, and then take the last part, multiply by itself, plus bi, we have to square that. Fantastic. Now let me move back a little bit. So we're saying 3 minus 4i is equal to, this is a squared plus 2abi, and then the last part there is going to be plus b squared times I squared. Now, in terms of complex numbers, I squared actually should be equal to minus 1. So basically we are saying 3 minus 4i is equal to a squared plus 2abi plus b squared times minus 1. So I squared equals minus 1. Always remember this when it comes to complex numbers. Let me write it using a red pen here. I think this one will be darker. You must always remember that I squared is always equal to minus 1. So that's a very important aspect or concept to remember in complex numbers. Now let's expand, let's simplify this right hand side here. We are going to have a squared plus 2abi and then minus b squared. That's 3 minus 4i, giving us that. Now, so on this point here, I'm going to have to rewrite on the right hand side as follows. The left, we still have 3 minus 4i. On the right hand side, I'm going to put real numbers together. So a squared minus b squared is the real part, and then plus 2bi, this is the complex part. And therefore, we are going to say the real part on the right hand side should be equal to the real part on the left hand side. And yes, the complex part should be equal to the complex part. So we form two equations as follows. We put these papers in order. So we form two equations as follows. Right. So we are saying basically that a squared minus b squared equals 3, and 2ab, it's supposed to be 2ab this. Please remember that it's 2ab. So that's 2ab. I'm going to do this. Put a there, 2ab, because we have 2ab over here. So 2ab is equal to minus 4. So we're equating the coefficient on the left to the coefficient on the right. All right, now this simplifying this equation here, let me call this equation 1, and let me call this equation 2. Taking equation 2, which is 2ab equals minus 4, divide by 2 both sides, ab equals minus 2, and making b subject to the formula, we have minus 2 over a. Let's call this equation number 3. Now we substitute equation number 3 into equation number 1 to get what? What we get is the following. We're going to get a squared minus, in the place of b, we're going to put minus 2 over a. We square that, and the answer must be equal to 3. Simplifying this, it's a squared minus, and that will be 4 over a squared equals 3. At this point, I'm going to let a squared be equal to some number k. And therefore, this equation here will change as follows. You substitute this into that. Let's call this number 4, for example. And then we're going to say sub 4 into a squared minus 4 all over a squared equals 3. And what do we get? Where there's a squared, I put k. So what we get is the following. We're going to get, we're going to get k minus 4 over k is equal to 3. Multiply by k throughout, it will be k squared minus 4 equals 3k. Writing this in standard form, being a quadratic equation, we have k squared minus 3k minus 4 is equal to 0. Factorization of this, again, I've explained how you factorize a trinomial or a quadratic function like this one on my videos that you can easily access on my YouTube channel if you're watching this from TikTok. But if you're watching this from YouTube, you can actually just go to grade 10-9 work on algebra. You will see how to factorize this. But I'm just going to go quickly here and say how you factorize this. Maybe let me just explain it. You take this, multiply by that. The answer is minus 4k squared, and that's called the product. But the sum is the central part, which is minus 3k. So I said this is the product, and on the other side, that's the sum of what? Of two factors whose product is this and whose sum is that. If you check, the two factors should be minus 4k and positive k, because when you add these up, you get that minus 3k. When you multiply these, you get that. So these two must come and take the place of minus 3k. So what are we saying? We are saying rewrite these two. Remember, this is positive k. So plus k squared plus k minus 4k, and then minus 4 equals 0. So that expression has been placed by these two terms. But we're going to group these two and those two. So grouping terms, the common factor there is k. K into k squared is k. K into k is 1. The common factor here, as you can see, is minus 4. Minus 4 into minus 4k is k. Minus 4 into minus 4 is positive 1 equals 0. And common factor there is k plus 1. The other bracket must contain k minus 4 equals 0. And this means either k plus 1, this one here, equals 0, or k minus 4, that one equals 0. When the product of two numbers equals 0, either one is equal to 0 or the other is equal to 0, or both are equal to 0. So here you get k equals minus 1, minus 1. On the other side, you get k equals 4. Now, let me just clean up here a little bit. Yeah, we have minus 1 there, or k equals 4. Now, let's go back. What are we saying? Remember, k is equal to a squared. So we're going to say a squared is either equal to minus 1 or 4. So therefore, a squared is equal to minus 1 or a squared is equal to 4. Now remember, a is the real part. I told you that a complex number has the real part and the complex part. And therefore, there's no real number a whose square is minus 1. So this one here will not provide a solution, not applicable, because a squared can never be negative. So from here, we're going to get take square root both sides. You'll agree with me that the answer is going to be, taking the square root of that, the answer is going to be square root of a squared. You're going to have plus or minus 2. So what is a squared? What is a? Sorry, the a value of course, I've already taken the square root of 4 there to be plus or minus 2. So basically, we are saying a equals plus or minus 2. Yeah, like that. On the right hand side, if you want, you can also write this as square root of, we delay that, let's keep 4 there, delay it just a little bit, and what is the square root of 4 is 2. So we have plus or minus, because that's a quadratic equation. We know we can square minus 2, we get 4. Square 2, we get 4. All right, so now we got our value of a, taking us to page 4. Now that means we must go back now to find the value of b. And where are we going to? We're going to page 2. Here is page 2. The value of b is 2 over a. So we're going to say b equals 2 over minus 2 over a. It says, as you can see here, minus 2 over a. So we're going to say, when a equals minus 2, remember the values of a are 2. We have here plus or minus 2, as you can see. A equals, the papers are not in order here. You can see that a equals plus or minus 2. So we are saying when a is minus 2, what is the value of b? B will be minus 2 over minus 2, and the answer is 1. And when a is equal to positive 2, plus or minus 2, when a equals positive 2, b will be equal to minus 2 over 2, and the answer is minus 1. So we must go back to page 1 now. What does page 1 say? Here is our page 1. Page 1 says that must be equal to that. So we're going to say, therefore, the square root of 3 minus 4i, which we said is equal to a plus bi, must be equal to, when a is minus 2, b is positive 1. And what is this? This is minus 2 plus I. Or the square root of 3 minus 4i must be equal to, we're here, but a is 2 this time. B is minus 1. Remember, b is minus 1, I. And simplifying this, you'll agree with me, the answer is just 2 minus I. And so we can say, therefore, the square root, what we are required to evaluate, of 3 minus 4i is actually equal to minus 2 plus I, or positive 2 minus I. I am going to request you to, maybe we should try and do that, just to check. Multiplying this by itself to see if it gives us that expression down there. So we are saying, basically, just do that very quickly. We are saying we want to check if we square that, do we get this? What is under the square root sign? So minus 2, so this is page 6 now. And I hope to be fast enough there to be able to perform that. Am I on page 6? Let me check the pages. Page 4, page 3, it's actually page 5, not page 6. It's page 5. So on our page 5, what I want to work on is minus 2 plus I. We want to check. When we square this, what do we get? Well, remember, minus 2, we square it, plus multiply these two, double, minus 2i, and then plus multiply that by itself. This is going to be 4, and this, you'll agree with me, it's minus 4i plus that I told you already on page 2, I think. The square of minus I, the square of I is actually equal to minus 1. I is imaginary, any imaginary number I. This is going to be minus 1. And what are we saying? We're saying this is 4 minus 4i minus 1. And if you take these two together, it's going to be 3 minus 4i. So yes, correct. It makes sense that the square root of this expression here is actually that. Let's try that. Okay, maybe I will say leave that one. I'll leave it to you to try and square that and see if it gives you that expression under the square sign. Right, like I promised at the beginning, I will come up with another video that addresses the basics of complex numbers. I am going to stop here in this one. I hope you found it that useful. I'll see you in the next one.